Hello there, this is Alana Tuckey. This is going to be the lecture video for Math 131, Section 8.1, Part 1, where we are going to be dealing with rational expressions, both their domain and how to reduce them into lowest terms. All right, let's start off with finding the domain of a rational function. Well, actually, before we even do that, let's find the definition of a rational expression. This is new for Chapter 8. A rational expression, which is also known as an algebraic fraction, if you've ever seen that term, it means that you have a fraction of the form p of x over q of x, where both p of x and q of x are polynomials. Now remember from chapter 6 that polynomials means they have variables and constant terms with coefficients, and all the variables are raised to whole number powers, like 2, 3, 1, and so on. Now the domain of a rational function is all possible inputs or x values. So it's the set of all numbers except those that would cause the denominator to equal 0, because that is very, very, very bad in mathematics. You're not allowed to divide by 0 in algebra. Okay then, so let's look here. So we have this function f of x equals 2x minus 1 over 3x plus 4. So to figure out the domain, what I first need to figure out is what I cannot have in my denominator. So I have 3x plus 4, and that cannot be equal to 0. That would be terrible. Okay, so let's see here. That means 3x, I'm going to subtract 4 from both sides. You treat a not equal sign just like you treat an equal sign, right? So you'd say 3x cannot be negative 4, which means now you divide both sides by 3, right? And then over here, this is going to reduce because 3 over 3 makes 1. So x, oopsie, cannot be negative 4/3. All right, so then what's our domain? Our domain is all the possible inputs except that number. So you'd say the domain is all real numbers except negative 4/3. Now, the other way to write this, besides this, because mathematicians are kind of lazy and they don't really like writing all of the all real numbers portion. So what they'll sometimes do is a fast abbreviation way to say it, which is right here. See, my little math type machine has it anyway. So it's like an R with an extra bar on the left is how you write it when you write it by hand, except negative 4/3. There we go. Done with that one. Next. All right, so now for this, we need to know the domain as well for here. So we need to be able to solve that denominator, set it equal to 0, and that'll be all the numbers you can't have. There, I had to make that smaller to fit on the screen. Okay, so we're going to make this denominator, what is it, a squared minus 3a minus 10 cannot be 0. All right, so treat that just like an equal sign. So you'd say a and a, we can factor this. It's minus 5 and plus 2. We learned how to do all of that back in chapter 7, or actually chapter 6, right? Okay, so if a minus 5 times a plus 2 is not 0, then either a minus 5 is not 0, or, oops, too many R's there, and then a plus 2 can't be 0. There we go. All right, so this means, oh, and I don't need that parentheses there. That was my fault. So a minus 5 is not 0, and a plus 2 is not 0. Okay, then we would add 5 to both sides here. So you'd say a cannot be 5, or a cannot be negative 2 because you'd subtract 2 from both sides. Here. And that's what you're doing. And then over here, you're subtracting 2 from both sides. Okay, so now what's our domain? Our domain is all real numbers. So the R with an extra bar in it, except negative 2 or 5. And there's our domain. We can have anything except for those two numbers, because those two numbers would cause division by 0 in the original expression, the original function. All right, let's move on. What about the next one? Okay, so we're going to have to take that denominator and set it equal to 0. So 2x cubed plus 8x squared minus 42x. And this cannot be equal to 0. All right, this cannot be, cannot be 0. All right, now we need to practice our factoring skills that we learned in chapter 6. So let's take a 2x out because that's our GCF. That'll leave us x squared plus 4x minus 21 cannot be 0. So 2x, and now we'll do a double parentheses. Cannot be 0. All right, so we're going to have x and x plus 7 minus 3, right? Because that'll give us minus 21 for our lasts, but outers and inners will make 4, right? All right, so now you have three things. You have the 2x, that can't be 0. So let me multiply this. All right, so you have 2x cannot be 0 right here. Then you have the x plus 7 cannot be 0. Or you have x minus 3 cannot be 0. And then you can solve each one of them. Well, this one's really easy to solve because if you have 2x is not 0, then you divide both sides by 2. And 0 over 2 means 0, so x cannot be 0. So there's one solution right there. All right, then what about this middle one? Well, you could subtract 7 from both sides. There you go. Minus 7, minus 7. So that means you're going to have an x cannot be negative 7. This one you're going to have a plus 3 and a plus 3. So you're going to have x cannot be 0. X cannot be negative 7. Or x cannot be negative or positive 3. Okay, so what's the domain then? The domain, which is the actual question they were asking, is all real numbers except 0, negative 7, or 3. And you're done. Last but not least, let's do this one. So we have t squared plus 16 cannot be 0. All right, so there's a couple different ways we can go with this, but for example, you might just know right at the second, but I'll prove it to you. There's no solution here, so but let me show it to you. So if you subtract 16 from both sides, you're going to say t squared cannot be negative 16. Okay, so then what do we do when we have something like that? When you want to solve that for t, you take the square root of both sides, plus or minus, right? So you take the square root over here, take the square root over here, plus or minus, like that. Ah, okay, but this is a negative under a square root. So that means t cannot be plus or minus 4i. Ah, but I is an imaginary number, and we're working in the real numbers here, right? So we're saying all real numbers except all real numbers except all real numbers. So I could put any real number in. I just can't put in an imaginary 4i or a negative 4i. So that means all real numbers. is my domain. And again, the fast way to write that would be to say this special little r with an extra bar in it. That means all real numbers. So any real number is possible because the only numbers that would make this 0 aren't real. They're imaginary. And again, that doesn't mean they're imaginary like they don't exist imaginary. It's imaginary in that it's not in the real number system. All right? Okay, so we are all done with that one. Let's stop right there for this video, and the next video we'll practice simplifying expressions. So I'll see you then.